Hey there, Hampshire chemistry students. Glad to have you today. I hope you're all enjoying your first blended day. I want to take a look at some discussion about different types of laws we're going to be using in chemistry and some different equations. So let's take a look. First, though, I do want to make sure we understand what's happening in these types of videos when we're going over them. Three big rules. First off, write everything. We're going to be writing down some equations and different definitions. You should have them down on your own piece of paper or on your own Chromebook. Next, do stuff with me. If I'm pulling out a calculator and doing math, you should be doing the same too. And lastly, pause and replay. I will be going quick, quicker than I would in any other normal video. So make sure you pause and go back if you need that extra time. In this video, we're going to be taking a look at gas laws. Specifically, our goal is that we can identify and use the three major gas laws. In this video, we're going to focus on identifying. So let's identify those three big terms. Our first term is called Boyles Law. And Boyles Law shows an inverse relationship of two variables, that is pressure and volume. We'll often use P and V to represent these different variables. Now, what do we mean when we say inverse relationship? It means we're talking about when we have something like an increase in pressure. This type of relationship, you will see the inverse. You will see it decrease in volume. While one goes up, the other goes down. You could think of this like a syringe. If I am going to add some pressure to this end and I've sealed the other end with my finger, we can see that that volume decreases and I end up pushing more and more, and if I let go, it expands again. It's that opposite relationship. So I could increase pressure and see a decrease in volume, or if I decrease pressure, I would expect to see an increase in volume. So that is our basic relationship, but we also have an equation that we can write from this, and it involves pressure and volume, and it looks a little bit like this, that I take P, that stands for pressure, times volume, and that is going to be equal to, on the other side, P times volume, pressure times volume. Now, you might be wondering, what the heck? These are both exactly the same on both sides. And that's because this represents a change. So we see on the left-hand side, I'm going to write P1 and V1. And then on the other side, I'm going to write P2 and V2. So this represents a before state and an after state. So we can show a change between a different scenario, like before I push down and after I push down. We can figure out what's happening in these different types of equations. So again, make sure to pause if you need to. But let's take a look at our second gas law. That is called Charles' Law. So Charles' Law, this guy shows the direct relationship between volume and temperature. So direct relationships are different than inverse relationships because in this type of relationship, if I increase volume, we see directly the same thing, an increase in temperature. Notice that's different because here we had the inverse relationship. One went up, one went down. These guys both increase together. They can also both decrease together. Where one goes down, the other goes down. So our equation for this is going to look a little bit different. We have volume and temperature. And this guy's going to look like this. I have V over T equals V over T. Right, don't forget, we are going to do those 1s and 2s to show that before and after. So that's our Charles' Law equation. Now, we do have a very special rule here with using Charles' Law, and that is with the temperatures. Notice the temperature is in the bottom of the equation, which means that if I had like 0 degrees Celsius as my temperature, I'd run into a crazy problem with my calculator, right? If I have like 100 milliliters divided by 0 degrees, calculator gets angry at me, right? So we need something to fix that. When we work with temperature in our gas laws, we need to make sure that we are always using a very specific unit. Right? We are always going to have our temperatures being in Kelvin. We're going to take a look at this more in our math example in the next video, but the way you calculate the Kelvin temperature is very easy. You just take the degrees Celsius and you add 273. So make sure you have this down for our hint on our temperatures, and we're going to take a look at our final gas law after our Charles' Law, and that is called Gay-Lussac's law. Gay-Lussac's law shows another direct relationship, again, this time between pressure and temperature. So direct relationship meaning, again, you have that increase in pressure, you expect an increase in temperature. Okay? Or if you see a decrease in pressure, you expect a decrease in temperature. Not P, in T. So this equation ends up looking a lot like Charles' law, except now it's P over T equals P over T. So 1 and 1, 2 and 2. Okay. This is, again, another direct relationship, making sure you guys can see there. Okay. And again, don't forget, these temperatures must be in Kelvin. So we're going to be using all three of these different gas laws together in the next video. So please make sure you have all these guys down. Go back and review and replay if you need to. But for now, let's get into using some of those gas laws.